Since this has so many different variables in it, it doesn't come as a big surprise that they might ask us to find a different variable. We've already done finding E sub A. Let's try something else. Here is a reaction between ozone and nitrogen monoxide, and they've given us the activation energy. Then it says how many times larger is the rate constant for this reaction at 400 Kelvin compared to 200 Kelvin. And at first, we might be tempted to panic because they gave us both the temperatures, but they did not give us one of the Ks. I've got this filled in. I'm going to have these filled in. Let's look at the wording. How many times larger is the rate constant for this compared to that? Oh, that's okay then. They're just asking for a ratio, and that is a ratio. It's already set up as a ratio. I just have to make sure that I get them in the right order. They want the rate constant for the reaction at 400 compared to 200. How much larger is it for at 400 compared to 200? The subscript of 1 is going to be the situation at 400 Kelvin, and the subscript of 2 is going to stand for the situation at 200 Kelvin. So natural log, I only care about the fact that there's a ratio. I'll fill in these. Now R, I have to remember, is the 8.314, and that's joules per mole Kelvin. So up here, where they told me it was 10.2 kilojoules per mole, I should keep in mind that that is going to convert, because every kilojoule, kilo simply means 1,000, so is 1,000 joules. So I've just translated the word kilo into the number 1,000. So I'll end up writing over here 10,200 joules per mole. And you can see the joules and the moles completely cancel out right away. And then over here, so this will be 1 over 200, and this will be 1 over 400. When I get all done with that, I will find out that the natural log of ratio is going to be 3.067. Undoing a logarithm means I need to use E. E raised to this equals E raised to that. That will just knock these out. And I'll have K1 over K2. And when I round this back to 2 sig figs, I'll get 21. So K1 is going to be 21 times K2.